For countless generations, humanity has looked up at the vast expanse of the night sky, filled with curiosity about the universe's many unsolved mysteries. In the 20th century, scientists introduced the Big Bang theory, which attempted to explain the origin, evolution, and expansion of the cosmos. However, despite its widespread acceptance, this theory still struggles to answer some of the most fundamental questions about the universe. New discoveries in recent years have added even more complexity to these cosmic riddles. For example, in 2023, NASA's James Webb Space Telescope made a groundbreaking observation. It detected celestial bodies that appear to be older than the universe itself. This revelation has left experts astounded and has sparked a debate on whether it's possible for stars to exist for a period exceeding the universe's age. This paradox challenges our current understanding of cosmic events. Does this anomaly imply the need for a completely new model of the universe? These questions, and many others, will be explored in this video. If you wish to stay updated on the latest cosmic developments, don't forget to subscribe, like the video, and activate the notification bell. Around 200 light-years from Earth, in the constellation of Asen Lie, resides a star known as HD 140283. What makes this star particularly intriguing is its incredibly high velocity, moving at 44.83 kilometers per second, which provides valuable insights into its tumultuous history. Around 1 billion years ago, during a period when our Milky Way was still forming, it collided with a dwarf galaxy, which was home to this particular star. However, the most astonishing feature of HD 140283 isn't its speed, but its age. This star is one of the oldest celestial bodies ever observed, earning the nickname Methuselah in reference to the biblical figure who, according to legend, lived for 969 years. Initially, estimates suggested that its age was a staggering 16 billion years, but newer calculations have revised that to 14.46 billion years, with a margin of error of about 800 million years. This discrepancy creates a significant puzzle when compared to the current estimate of the universe's age, around 13.8 billion years, as determined through observations of the cosmic microwave background. This raises the pressing question: how could a star be older than the universe itself? This seems impossible based on our current understanding. This paradox has led scientists to reconsider the accuracy of our methods for dating both stars and the universe, prompting further investigations into these astronomical mysteries. To better understand this issue, it's essential to recognize the challenges involved in calculating the age of celestial bodies. Stars like our Sun maintain relatively stable temperatures and sizes over billions of years, making their age difficult to determine with precision. Astronomers analyze subtle changes in a star's brightness and color over time, then compare these observations to theoretical models that predict the life cycles of stars. One key indicator for determining the age of a star is its rotation speed. Just as a spinning wheel slows down due to friction, stars gradually lose rotational speed. By comparing the rotation rates of stars of various ages, astronomers have developed mathematical formulas that allow them to estimate a star's age using a method called gyrochronology. Methuselah, the star in question, is indeed ancient. Based on current estimates, it is the oldest known star in the universe. Rather than pondering if it could be more than 2 billion years older than its surroundings, we can approach this from a different angle. Could it be that the universe is not as young as we once thought? Understanding the vastness of 13.8 billion years is no simple task. If we were to condense the history of the universe into a cosmic calendar, where the Big Bang marks the striking of the New Year's bell, Earth would only emerge toward the very end of December 31st, while human history would only span the last few seconds of the year. Astronomers calculate the universe's age by studying light from distant stars that formed hundreds of millions of years after the Big Bang, while the universe continued to expand, creating the phenomenon known as redshift. By evaluating both the observable distance and the expansion of the universe, the current estimate for the universe's age is 13.8 billion years. However, new research from the University of Ottawa has proposed an intriguing theory suggesting that the universe might actually be much older, around 26.7 billion years. Professor Rajendra Gupta, a physicist from the University of Ottawa, has presented a hypothesis that combines Swiss astronomer Fritz Zwicky's 1929 theory with new concepts in physics. His theory suggests that protons lose energy over vast distances and times, a concept that contradicts current data about redshift. Gupta proposes that by allowing this theory to coexist with the universe's expansion, we could reinterpret redshift as a hybrid phenomenon, not solely attributed to expansion. This reinterpretation could lead to a new estimate for the age of the universe, potentially offering solutions to long-standing cosmological questions, some of which have recently arisen in the wake of NASA's findings. Gupta's work builds upon the tired light theory and the concept of evolutionary interaction constants, originally proposed by theoretical physicist Paul Dirac, suggesting that certain cosmic interactions may have evolved over time. It's important to note that our understanding of the universe's age has evolved over the years. For instance, in the 1920s, Edwin Hubble proposed that the universe was only about 2 billion years old, but subsequent observations have dramatically increased this estimate, eventually reaching the current consensus of 13.8 billion years. Regardless of whether we consider human history as a mere 10 seconds or 5 seconds on the grand scale of cosmic time, it is clear that the universe is extraordinarily ancient. Its continual expansion forces us to reconsider previous assumptions about its age. At the same time, there are intriguing new findings regarding our own Milky Way galaxy. Recent measurements indicate that stars in the outer regions of the Milky Way move at a much slower pace than their counterparts in other galaxies. Several possible explanations for this phenomenon have emerged. One suggestion is that our galaxy may contain an unusually small amount of dark matter, an invisible substance that plays a crucial role in the gravitational forces of cosmic bodies. Another possibility is that our understanding of dark matter and its distribution throughout the universe might be fundamentally incorrect. This dilemma stems from data collected by the European Space Agency's Gaia satellite, which has mapped the positions of nearly 2 billion stars within the Milky Way. These observations have prompted astronomers to reconsider their models of stellar behavior, particularly in the galaxy's outer regions. The speed at which stars travel is an essential factor in calculating a galaxy's mass, as the gravitational forces on stars depend on the total mass of the galaxy. A recent study, based on data from the Gaia satellite, suggests that the mass of our galaxy, including gas, dust, stars, and dark matter, is around 200,000 billion times the mass of our Sun, 5 times lower than previous estimates. However, calculating a galaxy's mass is notoriously complex, and there may be uncertainties in the data from the Gaia satellite or the analysis methods employed. As new information becomes available, we will continue to monitor these developments closely. In the coming years, advancements in technology and new space missions will likely shed more light on these pressing cosmic mysteries. The James Webb Space Telescope, with its unparalleled capabilities, is set to continue pushing the boundaries of our understanding of the universe. It's not just the age of stars or the universe itself that we are trying to understand, but also the intricate dynamics of galaxies, dark matter, and the forces that shape cosmic evolution. The expansion of the universe remains a central focus of astronomical research, but as we gather more data, we might find that our earlier assumptions were incomplete, or even incorrect. The coming decades could provide answers to questions that have puzzled humanity for millennia. Whether it's the potential of older stars or the deeper mysteries of dark matter and dark energy, the universe still holds many secrets waiting to be unraveled. The path forward is one of exploration, hypothesis, and continuous refinement of our understanding of the cosmos. So, while the answers may not be clear yet, the excitement of discovery is only just beginning. Stay tuned for more updates on these groundbreaking studies and theories. Keep your curiosity alive. Who knows what new frontiers of knowledge we might discover next? With the James Webb Space Telescope sending back more data than ever before, astronomers are beginning to question not just the age of the universe, but also whether our current models of cosmic evolution are complete. Could it be that our understanding of time itself is flawed? Some physicists suggest that time may not be as linear or absolute as we once believed. If time behaves differently in extreme gravitational fields or vast cosmic distances, it could mean that our measurements of the universe's age are missing a crucial variable. Meanwhile, deep in the heart of our Milky Way, another unexpected discovery has sent shockwaves through the scientific community. A newly observed star cluster, hidden behind dense cosmic dust, appears to contain elements that should not exist in such an ancient system. The chemical composition of these stars suggests they formed under conditions that do not match our models of early star formation. Some researchers speculate that these stars could be remnants of an even older universe, hinting at a cosmic cycle of birth and rebirth far beyond the scope of the Big Bang theory. At the same time, physicists working on dark matter detection experiments are finding more anomalies in their data. Recent results from underground observatories suggest that dark matter particles, if they exist, may interact with normal matter in ways previously unaccounted for. Instead of being entirely invisible and non-interacting, as once believed, dark matter may possess subtle, unknown properties that occasionally allow it to interact with ordinary atoms in ways we have yet to fully understand. Some researchers even propose that dark matter could be linked to an undiscovered fundamental force, one that operates alongside gravity, electromagnetism, and the nuclear forces. If this is true, it could revolutionize our understanding of the very fabric of reality. Meanwhile, astronomers using the James Webb Space Telescope have detected something even more astonishing: a galaxy so massive, so luminous, and so old that it defies every existing cosmological model. The galaxy, dubbed XG 472, appears to have formed just a few 100 million years after the Big Bang, yet it contains fully mature stars and complex structures that should have taken billions of years to develop. This finding suggests that either the universe evolved far more rapidly than we believed, or our entire concept of cosmic time needs revision. As the implications of these discoveries ripple through the scientific community, a bold new hypothesis emerges. What if the Big Bang was not the absolute beginning, but merely one phase in an eternal cycle of cosmic rebirth? Some theorists propose a phoenix universe model, where the cosmos expands, collapses, and re-expands in an infinite sequence. If true, this would mean that remnants of previous universes could still exist within our own, hidden in the oldest stars, the deepest voids of space, or even within the mysterious nature of dark matter itself. At CERN, physicists push their particle accelerators to new limits, searching for clues that might confirm or refute these radical ideas. Could the elusive dark matter particles, or even the newly proposed dark photons, be remnants of a previous cosmic era? The data is inconclusive, but the excitement among researchers is undeniable. Then, a signal arrives. Buried within the noise of deep space radio transmissions, astronomers detect an unusual pattern: anomalous pulses of energy coming from a region of space where no known galaxies or pulsars exist. Unlike normal cosmic radio bursts, these signals do not decay or disperse in expected ways. Some scientists wonder, could this be a message? Not necessarily from extraterrestrial intelligence, but perhaps from the universe itself, an imprint left behind by a previous cycle of cosmic existence? The race is on. Teams of astrophysicists, cosmologists, and quantum theorists unite in an unprecedented collaboration, working to decipher whether these signals hold the key to unlocking the greatest mystery of all, the true nature of a universe. If they succeed, humanity may finally glimpse beyond the veil of time itself, beyond the Big Bang, beyond dark matter, beyond everything we thought we knew, into the endless, uncharted realms of a cosmos that has existed forever.